the only real change come from inside. But the only real change come from inside. But the only real change come from the cemeteries unchanged. I see men cry. But the only real change come from inside. But the only real change come from inside. But the only real
Good morning, Mr. Duck is back at it again. Congratulations, you passed the test. Now you're going to expand and condense exponents.
So just like that guy with the cookie had said, we're going to expand and condense exponents. Before we do that, let me just tell you or remind you what exponents are. Right, we've got a base, bam, base. That is this 5 right there. That's the thing on the bottom. And the exponent, that is the power. That is that little 3. So we write this might seem a little familiar, that we say this is 5 to the third power. So that's how we say what this is right here. And the base is 5, that's being raised to the third power. And what it really means is the base, which is 5, multiplied by itself as many times as the power says. So the base is 5, we do 5 times 5 times 5 because it's 5 to the third power. So now we're going to expand some exponents. So I'm looking at this right here. This is 2/3 to the third power. So the base, let me get a pen. The base is 2/3 and the power or exponent is 3. If we expand this, this means 2/3 times 2/3 times 2/3. So we take the base, we multiply it by itself 3 times because the exponent is 3. The next one, the base, this is going to be -2. And the power is 5. So if I expand this, I do -2 multiplied by itself 5 times. So -2 times -2 times -2 times -2 times -2. This is an expanded exponent. We're going to do a lot of these, so get used to them. So now we're going to condense the exponents. That's the opposite of expand. We're making them smaller. So I look over here, how many 4s do I have? 1, 2, 3, 4, 5, 6. So this will be 4 to the 6th power. The base is 4 and it's being multiplied by itself 6 times. Over here we have -3. That would be the base. How many times is it being multiplied by itself? 1, 2, 3. 1, 2, 3. Bam. -3 to the third power. Over here we have 2/5 multiplied by itself. How many times? 1, 2, 3, 4, 5. So this will be 2/5 to the 5th power. Cruising. Alright, over here, D, we've got x's. How many do we have? 1, 2, 3, 4. So that's 4 x's. The base would be x, and it's being multiplied by itself 4 times. Ooh, over here, we got 5's and y's. Oh my goodness. Don't worry, we can do it. We're just going to write 2 different things. So right here, we've got 5 times 5. Well, that becomes 5 squared, or 5 to the 2nd power. And that's being multiplied by y times y times y times y times y. So that is y to the 1, 2, 3, 4, 5 to the 5th power. Right, you can put a little dot there to show multiply, but if a number is right next to a variable, it already means multiply. And you might be thinking, Mr. Durkis, I know 5 squared, that's 25. So can I write 25 y to the 5th power? You can. This is asking you to use exponents though. So that's the practice. But if you do that, I'm cool with that. That's fine. Alright, the last one. We have letters and numbers again. So let's try this. We have 3 times 3 times 3. So that's 3 to the 3rd power. And then x times x, well that's x squared. And then y times y times y times y, that's y to the 4th power. Then you might say again, hey, Mr. Durkis, I know 3 squared. 3 times 3 is 9, times 3 is 27. So you could say 27 x squared y to the 4th. That's cool too. So we condensed. Now we're going to expand again. We did this a little on the front. Let's do it again. So 4 to the 3rd power. That is 4 times 4 times 4 You could figure what that equals. 4 times 4 is 16, times 4 is 64. But I'm really trying just to have you expand these. That's all I want right there. B, 2/3 to the 5th power. Well, that's going to be 2/3 times 2/3 times 2/3 times 2/3 times 2/3. Did I do it 5 times? 1, 2, 3, 4, 5. Yep, I am good. Alright, negative numbers. -3 to the 5th power. Ooh, why did I do a 5 again? That's a lot of stuff. Let me do it. -3 times -3 times -3 times -3 times -3. 1, 2, 3, 4, 5. Good. If you notice this one, I put the dots in between to show multiply. Over here I didn't. We have parenthesis next to a parenthesis. It means multiply. M to the 5th power. There's going to be 5 M's. M times M times M times M times M. Done. Alright, over here, numbers and letters. We can do this. We have 3 to the 2nd power, so that's 3 times 3. If we have numbers next to each other, always put the dot in the middle. And now we have x to the 5th. X, 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 X. Oh, you might be saying there's no dots. That's okay. If it's just letters, you can just put them right next to each other, and it means a multiply. Lastly, 5 to the 4th power, x squared, y cubed. So I can say 5 times 5 times 5 times 5 times x times x times y times y times y. Whew. Alright, we got the basics down. Now we're going to get a little bit more in depth. Now we're going to expand and simplify. So we've got this right here. Let me expand that. We've got 2 squared, which is 2 times 2, multiplied by 2 to the 5th. So I'm going to multiply by 2 5 more times. Times 2, times 2, times 2, times 2, times 2. And what will this equal? Well, the base is going to be 2 because they're all 2's. And how many do I have? 1, 2, 3, 4, 5, 6, 7. So that is really 2 to the 7th power. Alright, this one over here, we've got 3/4 times 3/4 squared. So this is really 3/4 times 3/4 times 3/4. And if we've got 3 of these, right, I can really say 3 times 3 times 3. That is 3 cubed. And 4 times 4 times 4, that's really 4 cubed. Interesting. Over here, we got -4 squared, so that's -4 times -4. Over here, -4 cubed, -4 times a -4 times a -4. How many do I have altogether? 1, 2, 3, 4, 5. 5. Ba-bam. Now let me expand some of these y's. We got y cubed, that's y times y times y. You might be thinking, why are we doing this? Why are we doing this? Because it's important. You'll find out. Y to the 4th, there's 4 y's. Y, 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 y. Now if I simplify that, how many do I have? We got 1, 2, 3, 4, 5, 6, 7. So that's y to the 7th power. This one right here, we've got 2 x cubed, that's 3 x's. 1, 2, 3 times 4. How many x's over here? Well, that's x to the 4th, so there's going to be 4. 1, 2, 3, 4. Now if I kind of smush them all together, 2 times 4 is 8. And how many x's will I have? 1, 2, 3, 4, 5, 6, 7. 8x to the 7th power. Last one, 3 to the 4th power. D squared times 3 times d to the 4th power. Let me write it out. We've got 3 times 3 times 3 times 3. That's the 3 to the 4th power. Times d, that's d squared. Times 3, d to the 4th. So it's going to be 4 d's. 1, 2, 3, 4. Now I need to smush them together. How many 3's do I have? 1, 2, 3, 4, 5. So 3 to the 5th power. How many d's? 1, 2, 3, 4, 5, 6. So d to the 6th power. All right.
So just dance.
right, now let's raise some exponents to another exponent, the power. So the first one, 2 cubed squared. So we see these parentheses, that means everything inside has to be squared. So we're going to write this out, 2 cubed times 2 cubed, just like that. Now if I expand these out, 2 cubed, that's really 2 times 2 times 2. And this is really 2 times 2 times 2. So what does that actually equal? Well, how many 2's do we have? 1, 2, 3, 4, 5, 6. So this equals 2 to the 6th power. So 2 to the 3rd power raised to the 2nd power really equals 2 to the 6th power. Woo! My brain just exploded. All right, over here, 5 cubed to the 4th power. So same thing. This is going to be 5 cubed times 5 cubed times 5 cubed. And, oh wait, one more, my bad. 5 cubed to the 4th power, 1, 2, 3, 4. Each of these can be written as 5 times 5 times 5. So let me write that out. 5 times 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 5. Whew! Alright, so how many 5s do I actually have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is really 5 to the 12th power. So 5 cubed to the 4th power is really 5 to the 12th power. Over here, we've got a variable. Is this going to freak you out? I hope not. We can do it. So I just write out the same way. This is x to the 4th, and it's squared, so I do it 2 times. If I break this down, this is really x times 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 x. How many x's do I have? 1, 2, 3, 4, 5, 6, 7, 8. So this is really x to the 8th power. Oh my God. Oh my goodness. All right, 2 more. And you might be thinking, do I really need to expand all these and write all this stuff out? Yes, you do. If I ask you to expand it, that's what I mean. That's the question. So we have to expand these. So 2x cubed. So that's going to be 2x cubed times 2x cubed times 2x cubed. If I write this out, this is really 2x times x times x times 2 x times x times x times 2 x times x times x. Now how many 2's do I have? If I smush it all together, 3, so it's 2 to the 3rd power. How many x's? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 2 to the 3rd power, x to the 9th power. Alright, ooh, this is a bigger one. We've got 4 cubed y squared, and all of that is raised to the 3rd power. So I need to write this 3 times. 4 cubed y squared times 4 cubed y squared times 4 cubed y squared. Then I need to expand those ones. So 4 times 4 times 4 times y times 4 times 4 times 4 times y times y times 4 times 4 times 4 times y times y. That's kind of like a song. That was pretty good. All right, so now I have 4. How many 4's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 4 to the 9th power. How many y's? 1, 2, 3, 4, 5, 6. Y to the 6th power. All right, almost done. So this is the last one. We're talking about quotients. This means dividing. So let's jump right in. This is 2 to the 4th power divided by 2 to the 2nd power. So on the top of the fraction, we have 2 to the 4th power. That's 2 times 2 times 2 times 2. And on the bottom is just 2 times 2. So we should look at it. Can anything cancel? So there's a 2 on the top right there and a 2 on the bottom. Those cancel. That 2 and that 2. And so I'm left with just 2 times 2, which is 2 squared. So 2 to the 4th divided by 2 squared equals just 2 squared. All right, let's do it with some variables. We have x to the 5th on the top, so that's x times x times x times x times x. There are 5 of those? Yep. On the bottom, x cubed, x times x times x. So what is going to cancel? Well, I'll take off 1x on the top, 1 on the bottom. I'll take 1 more on the top, 1 on the bottom, 1 more on the top, 1 more on the bottom, and on the top I'm left with just x times x, which is x squared. All right. Here we go. This one, it's got a number and some variables. Well, let's expand that out. We've got 10 on the top. How many x's? There's 7. 1, 2, 3, 4, 5, 6, 7. On the bottom we have 2 times x squared, which is just x times x. All right, what will cancel from there? Well, this 10 and the 2, I can simplify that. If I divide the 10 by 2, I get 5. If I divide the 2 by 2, I get 1. So I can really say 5 divided by 1. Now I'm going to cancel some x's. I got 1 on the top, 1 on the bottom, 1 on the top, 1 on the bottom. So if I simplify, how many x's do I have left over? 1, 2, 3, 4, 5. So I'm going to have x to the 5th. And this 5 divided by 1, that just becomes 5. So there we go. This big giant thing becomes that. Let's move over here. 3y to the 6. All right, so that's 3, and I got 6 y's. Why am I doing this? Why? It's going to be useful later, I swear. All right, on the bottom we've got 12 y to the 4th. 1, 2, 3, 4 y's. All right, let's simplify this thing. So 3 and 12. 3 can be divided into both of those. So 3 divided by 3 is 1. 12 divided by 3 is 4. So that simplifies to 1/4. Let me cancel some y's on the top, bottom, top, bottom, top, bottom, top, bottom. So on the top, I'm left with two y's, y times y. So that's going to be y squared. And this fraction is 1 on the top, 4 on the bottom. So I have 1/4 y squared. Bam, there we go, just like that. This can also be written y squared over 4 if you want. Either one's good. Okay, this is the last one. This one looks the craziest. So 2 to the 5th, x to the 4th, y to the 5th. I'm just going to write it all out. 2 times 2 times 2 times 2 times 2. That's 2 to the 5th. X to the 4th. 1, 2, 3, 4. Y to the 5th. 1, 2, 3, 4, 5. Oh man, look at all that. On the bottom, 2 squared. 2 times 2. X cubed. X times x times x. And then we got a little lonely y. There's no exponent, it really means 1. So I just got 1y. Let me cancel some stuff out. So there's a 2 and a 2. A 2 and a 2. X and an X. X and the X. X and the X. And then a y and the y. So on the top I have 2 times 2 times 2. 2 cubed. We've got an x. And then 1, 2, 3, 4. Y to the 4th power. There we go. That is it. We have expanded and condensed exponents in many different ways. Great job. So good luck on this packet. Good luck on the mastery check. And I'm going to end you with a game show fail where someone messed up some math in their head. All right, see if you can figure out what they messed up. Dirkus out.
Pericles would be greatly displeased to learn that in 2010, what European nation is up to its olives in debt? Kimberly
Greece
is correct.
Yeah!
You got 100 points. You're in control. You would have loved that last ace. Is there another one? Mickey, deal it.
It's a 5.
It's a 5. Kimberly, what do you want to do with that?
Okay, well, I am definitely not going to give it to Bo to set him up for an 11. I'm going to go ahead and pass it over to Sean.
And give me a 21.
Well, that means